Okay, I'm also gonna record, so you guys can watch this back. Okay, use Shaper 3D instead of Fusion, right? You can, but I'm not. I'm good for this workshop. I'm gonna use Fusion. So, what's it called? You might not be able to follow along. I think that might, but it's not working. Then will give me the download link. Okay, if you go to Fusion free version, if you oh wait, shoot. Okay, Fusion free version. Yep. Are you allowed to have open places? Like, you have nothing outside on top of one. Yeah, that's fine. Okay, cool. So I'm gonna assume everyone has KiCad installed. Right here, I'll give you guys 2 more minutes to have KiCad and Fusion installed, and then if that once that happens, we can move on. Okay. Hello, Ryan. Hello, Not a Robot. Hello, Space Vinny 8. We're about to start in 2 minutes. All I ask is that you have KiCad installed, which is you can find here. I'll send it again. Install KiCad there, and then also install Fusion. Fusion 360. Wait, shoot. Fusion. Personal. And then you also get Fusion. You can also get an education license, but that usually takes a bit to get. Yeah. After a session, could you post a pinned message on Slack for for recording? Yeah. Well, the recording takes a bit to process, so it might be a couple hours, but I'll send that. Okay, great. 1 more minute, and then we'll get started. How do you use Fusion on Linux? Okay. You can't use Fusion. Can you try Onshape instead? Which is kind of similar. The education license works on Linux, but like the web version that comes with the education license, but that's gonna take a bit to set up. So here you could try Onshape. It should be pretty similar. But anyways, okay. Everyone, we are going to start. So can everyone see my screen? Type in chat if yes. Yes, okay, great, cool. So what we're gonna do, I'm just gonna kill this little project. So an overview of what we're gonna do, we are going to, we're going to start a new KiCad project. We are going to import libraries, and then we're gonna design our schematic. We're gonna design our PCB, and that's gonna be our PCB done. And then for our case, we're going to model the base of the case, and then we're going to model like the plate, and then we're going to model like the top part, and then that'll be done. So we're gonna start with KiCad. So can everyone open KiCad like so? You should get a screen something like this. Let me know if you have trouble with that. Already open? Great. So we're gonna go to File, New Project, and then we're just gonna name this whatever. So I'm gonna name this Workshop 2 because it's the second workshop. Yeah, very uncreative. Bam. Okay. Is that Obsidian you saw? Yes, that is Obsidian. Good eye. Okay. What am I going through? A 5x3? Okay, for this one, we're just gonna do a 4-key macro pad. It's just supposed to be really simple. But yeah, I think. All right, cool. So, we should have make firmware too. Yeah, we might be able to get to that. I want to focus on the PCB in case, but we'll try the firmware too. Okay, so once everyone's done this, I want you to now go to your browser and then head over to the repository. Right here. So go here and then click download as zip right here. And so that should download the entire repository. And if you open it up, inside the extras folder, you should see this KiCad care package folder. We're going to use that. So just send a message in chat when you have downloaded the folder and unzipped it somewhere. Done. Good to go. Can I import a Gerber file into KiCad and edit it? I'm not sure. You could Google that later. Hello, Jocelyn. We just got started. If you have KiCad installed already, you could just open that, and then we are downloading the GitHub repository. Okay. Cool. So we're allowed to use things like spacers. If you can send me a part number, yeah. Okay. Does everyone have the files downloaded? Yep. Okay, great. Okay, cool. So now we're gonna go into KiCad, and then we're going in the top, if you have preferences, you should see manage symbol libraries and manage footprint libraries. So symbols are basically what you see in like schematics. Does everyone here know what schematic is, or do you want me to go over that as well? You know what schematic is? Okay, so we're gonna start with a schematic. So what schematic is, it's basically like, what's it called? It's basically like a diagram of like all the connections. So if we go into like, sorry, let's like pick out a random schematic from like the Hackpad channel, right? So, okay, so for example, this person's schematic, it shows like all the connections, right? So here's like the microcontroller, and then they have like rotary encoders, which are like little knobs that you can turn. And then they have like a couple switches here. And so it basically, it like tells you where all the connections are. It doesn't tell you where it physically is on the control board, but that's the next step. So once you have the schematic, what you can do is then you could design the actual PCB because it knows where all the connections are. So you could just place it and then move all the parts together. So what we're going to do first is we're going to first design the schematics so that we know how to connect everything, and then we're going to actually connect it on the PCB. Does that make sense? Awesome. So what we're going to do, we can open KiCad. And so for our project, we need a few special symbols that doesn't come with KiCad. So we can add them. So we're going to go to manage symbol library. Symbols are what you use on schematics. So we hit that and then navigate to the project specific libraries tab. And then if you click the folder button down here and then go to wherever you downloaded it, I put in my downloads folder. If you go to extras and KiCad care package, and then you want to open this .kicad sim file, hit open and then save. Or okay, I guess here. That basically imports the footprint for what we need to do for our project. Just send a message in chat when you're finished that, and we can move on after. And import the symbols, nice. Okay. You're gonna go play some Helldivers too, see you lads? I get it. It's okay. Is the shape you have to make on the PCB what it would physically look like? So the PCB, yes. So if you look at this person's example, this is their schematic. The shape of the schematic doesn't really matter at all. You could make it in a spiral if you want to. Apparently you don't have a global symbol library table. Can you send a screenshot of what it shows you? You'll send the Slack? Okay, great. I'll check the Slack. And once we have the schematic now, once we import the symbol, we're also gonna import a footprint. So I'll show you how to do that after. And then we can start actually reading our schematic. Sent. Oh, just hit OK. Also, what is that theme? Is that like a custom Windows 98 theme? Okay, for those of you, or yeah, you guys can see what I'm seeing. Okay. Chicago 95 on Linux. Oh, nice. Great. Okay, so while some of you guys are still doing the importing symbols, I'll show you how to import footprint. It's the same process basically. You go to Preferences, hit Manage Footprint Libraries, and then go to Project Specific Libraries, and then we go to where we downloaded everything, and that's not the correct folder. Sorry. Okay. And then go to Extras, KiCad Care Package, and then you click the footprints.pretty folder, and so you open that, and then hit OK. There's a 3D model for the encoder, EC11 encoder in the Hackpad care package. It's not, but it is in the Hackpad, let's call it. It is on the Hackpad website, if I remember correctly. It might not be actually. If it's not, I'll add it later. 3D models. Okay, it's not. I can send it later. Tells you to select a file. Not a robot. Did you? Please select a symbol library to apply. Oh. Oh wait, does it let you select copy default global symbol library? Wait. Hold on, sorry. Can I, not, wait, okay, don't click anything so far. So I think it is. Wait, what Linux distribution are you on? Are you on Arch? Or in Debian? Debian, KiCad, a symbol table package. There should be a separate package for that, I think. I could be wrong. Here, can you touch base with me after? I'm going to move on just for sake of time, but one, there will be another workshop later that we can work with, and two, just reach out to me. I can catch you in between breaks, okay? So does everyone have like the symbols and the footprints imported? Yep. Yep. 1 second. Okay. One. Okay. Cool. We are going to go move on, I guess. What's called? Okay. Next, what we're going to do, we're going to open the schematic, and so you should get like this empty menu like this. Hope it works. Nice. Yeah. Okay. So this is like a blank slate for all your things. So what you want to do, you want to hit the A key, and then it's going to load up all your footprints. And this is basically like, this is where you can add like all your different components. You can just search something up, like I don't know, if I want to add a battery, I can add a battery, and then ta-da, it's a battery. But I'll be back soon. I gotta go get a haircut. No, you can't get a haircut. You have to stay. Okay. So let's go. We can add a let's go. We're gonna add our microcontroller. So search up RP2040, or not RP2040. Yeah, shell RP2040. This is what we want. And we can hit OK, and we add that. And then this is so much slower than the first workshop. Yeah, I did some reflecting, and yeah, we're gonna make this work. Okay, we're gonna make one. If we don't make one, we're gonna be close to making one, and you can finish it. This whole thing's gonna be recorded. It's gonna be great. Okay. So once we added that, we also need to like add our switches, right? So what we're gonna do, we're gonna search up like switch, and then the one we want to look for is one that you can push down. So we're gonna get that is not the correct footprint. You should search out. Did you import the one that I sent in the or did you import the one that we were working with earlier, Coder Kid? Oh, actually, that should work. Oh no, never mind. That footprint works. Yeah, sorry. Oh, I see. Okay. Actually, before I move on and add the switches, does everyone have this microcontroller imported? How do you add the switch? We can get to that in a minute. Yep. Yes. No, not yet. Still installing. Okay, not a robot. We'll get back into you. Not into you. We'll get back to you. The one you said works? Yeah, it works. Okay, cool. Jocelyn, great. Okay, so now we're gonna add switches. So we're gonna hit A again, and then we're gonna what's it called? We're gonna search up switch or SW underscore push. So we have a switch, and then we can just add that wherever we want. I'm just gonna put this here. So once we get a switch, we want more than one switch. So you can either press A again and add it multiple times, or here's my favorite move, you can just copy paste it. Just click that, Control C, Control V, and then Control V, and Control V. It doesn't matter where you place them, so you can just throw them here for now. Cool. Send a message in chat when you have 4 buttons placed down.
Wait, so I have a really quick question. So if we wanted like, I guess 9 switches, we would just have 9 of those?
You could do that, although what I would recommend is, let me, matrix wiring or keyboard. So this is why you see a lot of people be using, like, a lot of people use diodes. I'm gonna send this, or here, I'm just gonna send this in the Hackpad channel. You could read up on this and like look at how other people do it. But it's basically you can basically create like a multiplication table of switches. So like if I wanted 20 switches, I could do like a 5 columns and then like 4 rows instead of having. So I would only use 9 pins instead of using 20 pins.
Okay.
But we'll start small for now because it's easier to get. Okay, so we all have 4 switches. With you, and then wait, what do you do next? So if you hit A and then you search up shower here, if you double click that, it should import it. Scotto's tutorial uses 9 keys. Great. Could use a through hole for another version of the. We'll get to that. Okay. So once we have everything, imported, what we're going to do, we need to like draw the connections. So if there's a wire tool right here, you can also get by clicking W, but basically you can connect things together. So what we're going to do, we're going to connect one end of each switch to like a data pin. So on the microcontroller, there's like a couple different types of pins. There's like the power ones, which is like 5 volt, 3 volt, 3. And then there's like ground, which is like ground. Is the top diode correct? Yeah, that's fine. Can I verify this one? Looks good. Yeah, you'll be fine. Okay. So what we're gonna do, we're just gonna draw a connection from like a data pin to one end of the switch, like that. Does that make sense? Everyone got that? Yep. Can we do an example with the rotor encoder plus a 3 or 4 switches? Or 4 or 3 switches. We can't do that for this workshop, but what's it called? In the Hackpad repository, if you look at Orpheus Pad, which is another one I designed, that actually has everything you would need. It has 4 switches, a rotor encoder, an OLED, and 2 NeoPixel LEDs. So you could just reverse engineer the whole thing and then build your own. Yeah. Okay, so once we have one switch, we can wire the rest. So we're just going to wire that. Wire that. Wire that. Yep, looks great. If we make it to firmware, can you do a quick explanation of how to set up a rotary encoder in it if we have time after main stuff? Yeah, sure. How the NeoPixel LED solder? I thought we could only use 3 whole parts. Oh, well, you would just have to solder it yourself. You can use non-through-hole parts if you're okay with soldering. Okay. Does everyone have a schematic that looks like this? Okay, great. So, some of the more observant of you may have noticed that there's only one end of the switch is connected, but we need to connect the other end. And so what we're going to do, we're going to connect all of the opposing ends of the switch to ground. And so basically, when you press on the button, the power is going to flow from the data switch into ground, and the data switch, or not that switch, the data pin to the ground. And so the microcontroller is going to be like, oh shoot, there's power flowing. That means it's being pressed. So to do that, we're just going to hit P for power, and then we're going to search up GND, which is like the symbol for ground. And then we're going to add that. I'm going to throw one here, and then we're going to wire every single thing to ground. So like that, that, like that, and like that. Okay. Let me know when you guys have that done. And okay, while I'm waiting for everyone to finish that, Ryan, I'm just gonna throw this at you. Oh wait, shoot, wrong Ryan. Ryan Brandt, I think you are. No, wrong Ryan. Shoot. Ryan. Okay, there you go. Read up on that. It should help you. Okay, great. Everyone good? Is it okay if the connections overlap? You should be fine. I would suggest try to make them not overlap because it's easier to read. So like if you ever want to edit it in the future, it's like easier to read, but that should be fine if you want to just keep that for now. Okay. So once we do, so we're almost done our schematic. We only have one final step, which is to connect the ground symbol to the actual ground on the microcontroller. So we're gonna hit P again. We're gonna get another ground symbol, and we're just gonna place one here and then draw a wire to it like that. Yep. Nice. Do we need a VCC for pin 14? We do not, I think. Unless I'm missing something. Oh, no, we don't need to attach that because here, I'm just gonna go a quick tangent about like the theory behind this. Basically, we're pulling, so yeah. Sorry. Maybe okay. Cool. It's like basically when we press a button, we're pulling the voltage from the pin to ground. So we don't really need a VCC because it's already coming from the pin. Okay, cool. So does everyone have this set up? Yeah. Yeah. Okay, great. So we are officially done our schematic. Congratulations, everyone. Now, before we move on to PCB, make sure you hit Control S and save before the software crashes, so you don't lose all of your hard work. So I'm going to do that. So I just press save. And now I'm going to close the editor. And we can start on PCB. Yeah. Oh, wait, shoot. Actually, wait. Don't close that editor. Don't close that editor. I forgot a step. Okay, wait. Keep it open. Okay, so now that we have our schematic, we need to tell the software like what footprint to assign the symbol, right? Because right now we have a bunch of symbols, but our designer doesn't really know what to do with these symbols, right? So if you go up here and then you hit assign footprints, you can see all of our symbols, and it's looking for a footprint to be assigned to. Does that make sense? If it doesn't, just drop a question. Just say it again. Okay, so we have our schematic, but we don't actually. Our editor doesn't know how to convert this to a PCB, right? Like I can say there's a button here, but the editor doesn't know what a button looks like. So we have to assign what are called footprints to tell the PCB editor what a switch looks like. Yeah. Okay, that makes sense. Okay, so what we're gonna do, we're gonna hit assign footprints, and then we're gonna select our 4 switches. And then we can hit, I'm gonna search up Cherry, and you should see this footprint. Button, switch, keyboard, SW, Cherry, MX, whatever. So we're just gonna double click that. And as you can see, now our push buttons are assigned to a switch. You have a matrix, how do you go about wiring them into the shell? So what you want to do is each one of those tags. So this is outside the scope of this workshop, but for each one of those tags, you want to put it to one pin of the shell. So if you look at the example I have, it should give you a pretty good idea on how to do so. If not, or if there's some confusion, just reach out to me. It does, no. I mean, technically, there's some really niche cases, but I would not worry about that. Nothing comes up in filtered footprints. If you search up Cherry. Did you install the footprints? Or wait, does Debian have like a separate library for footprints too? You might want to check that. You install that too? Okay, here, we'll come back to you. I'm not sure what's going on with that. How do you get the cold tags? Okay, we can get back to you. So next we're going to install, what's it called? Next we're going to like match the footprint for our microcontroller. So you want to search up shell right here and then hit this one right here. And while I do that here, if you want CoderKit, you can also, or not CoderKit, not a robot, you can also try this library and see if that works. Okay, cool. Okay, yeah, so you just need to install it manually then. If you head over to that library, that should work. Okay. Cool. Everyone just drop a message in chat when you have all the footprints assigned. Done. Done. It looks the same though. Yeah. Yeah, you're fine. Don't worry about it. Does she have 2 I square C pins? I think it does. Do you mean 2 I square C? Because an I square C thing has 2 pins. Do you mean like 2 sets of I square C things? Let's check that out. RP2040. Let's see, it does have. No, it only has 1 set of I squared C pins exposed, but you should be fine. You shouldn't need multiple buses unless you're doing something crazy. You think you've done your footprint assignment? Okay. You can't find the second filtered footprint. Did you add it? It just shows the first one. Did you add the footprint earlier in what's it called? Did you add the footprint earlier? If you head over to Preferences, Manage Footprint Libraries, if you go to a folder and then Downloads, did you install this folder right here? Try that, and then I'll give you. Okay, we'll wait like another minute. Okay, cool.
Do we press apply and save or just okay?
Sorry?
So there are two options when assigning footprints. There's apply, save schematic, and continue, and just okay. So now press.
Hit apply, save schematic, and continue. Yeah, and then hit okay after. There's a bunch of stuff that starts with MX solderable. Not a robot. What you want is MX solderable -1u.keycat_mod. Okay, cool. I'm going to assume everyone's done their schematic for now. If not, no worries. You can watch this back after. Or you could just DM me for help too. That works too. Okay, cool. We can close our schematic editor, and then we're going to open our PCB. Ta-da! It's also a blank state. Yeah, that one right there. Cool. It's also a blank state. So, by the way, is everyone here, by the way, or does anyone have trouble opening the screen? Yeah, apply, save schematic, and continue. Done, continue. Yes, nice. Nice. All right. How are we doing? Yeah, everyone have the screen open? After that, you can just open the PCB editor. Yes, yep, okay. Is that connected to share properly? Looks connected. Yeah, you should be fine. Great. Okay, next we are going to hit this button over here, update PCB from schematic, because we have our definitions, we have our footprints. Now we just have to actually make the PCB. So what we do is we hit update PCB from schematic, and what it's going to do is going to read the instructions from the schematic, and it's going to like put them onto our PCB. So just going to hit this button. Hopefully you should say no warnings or errors. If you do, low key, it's probably fine. We should probably check it anyways. But yeah, so we're just going to hit update PCB. And then as you can see, it's going to barf out a bunch of components onto our screen. So yeah. Which button? It's this one right here. It's the fourth one from the right. I have a Blender button here. That's just a plugin. Don't worry about it. This one right here. I didn't use diodes. No, I did not use diodes for this tutorial workshop. Wait, wrong image. No worries. Can everyone just react thumbs up when they are what's it called, when they are done and like are at this step? Cannot add SW1 no footprint aside. Could you send a picture? Could you send a screenshot of like your assigned footprint definitions? like this screen right here. Wait like 30 seconds, no worries. How do you get to it again? So what you do, you go to assign footprints right here. Dude, I wish KiCad didn't have so many buttons, or they made like the important buttons more obvious. Because I feel like there's some really important buttons, but then they all look the same compared to like the ones that don't really matter that much. I wish filleted rectangles were easier to make. Yeah. KiCad, yeah. There's a couple tricks you could do. Like, again, I always like making things in Figma and then just importing it because it's easier than trying to edit it in KiCad, but I digress. Oh, yeah. So what you want to do, you want to select your push buttons and then like select these and then search up like MX, whatever, and then you just double click it when you have these selected and it should show you everything. And then you do the same for the microcontroller. You only clicked it once? Oh, yeah. Okay, I'll give you one more minute and then we're gonna move on to like actually making the PCB. And for the microcontroller, which footprint? This one right here, shell generic hybrid 14 pin, whatever, 2.54. Yep, no worries. Okay. So I'm gonna assume everyone has this down. If you don't, no worries. Again, it'll be recorded. There'll be more workshops in the future. There'll be 2 more today. So like, you can always come back around to it. Or during this 1 minute, what screws can we use? And just any M3 screw should work. I'll order them after you're done. I prefer, I think M3 by 16 or M3 by 20, 25. Screws will work. You'll do this whole thing again in every workshop? Yeah, probably. Because like people have different time zones, right? So people in like EST have school right now. And then like, the 6 p.m. when people in PST like California will have school. Great, nice job, my robot. Okay, cool. Hurricane saved me from that. Okay, that's really funny. Okay. So now we're here. So before we do our wiring, we have to do our arrange. We have to like arrange our components first, so that we know like how we want it arranged. So what I want to do, I'm gonna put the microcontroller to the side actually, and then I'm gonna put the switches together. So make sure that you see the white box around these switches, that's for like alignment. So you want the edges of each white box to touch each other so that the keycaps don't get smushed together. Because otherwise, like even though the switches will fit, your keycaps aren't gonna fit, and then you're just gonna have like a no keycap macro pad, which is gonna suck. Say again what I just said. Okay, so we're gonna arrange our components first before we wire it. So for this guide, I'm going to put the microcontroller on the right, and then I'm gonna put the switches on the left vertically. And what you want to do when arranging the switches is make sure that the white outline that they touch each other, because if you have them too close, they're not gonna the keycaps aren't gonna fit. 19.05 millimeter, yeah. But it doesn't have to be that accurate. Just make sure the box is aligned.
So they should touch each other, or they shouldn't?
They should. If you see my screen, this is what it should look like. I love KiCad. All hail KiCad. Actually, a lot of people hate KiCad, but you don't have the box in easy EDA. Okay. I don't. Well, see, this guide uses what's it called? This guide uses KiCad, so I'm not sure how to help you. Just try and make sure that like between each switch, there's like a center of each switch. Like if I measure from like here to, if I measure from like here to here, there should be like 19 millimeters. This is 18.9. It's basically the same thing. Yeah. Okay. So send a message in chat when you have everything arranged like this, and then we can move on. We can move on to wiring. Which is great. Done. Done. I'm using 19.05 grid. Done. Done. Great. Okay, so now we get to do our favorite part, which is going to be routing. So now that we have our components in place, we can route all the components we want together. So I'm going to start with all the ground. So if you zoom in, you can see the components actually like say where they're supposed to be connected to. So what you can do, you can select one of these pads, and then if you hit X, or if you have your mouse over one of these and then you hit X, it's actually going to like dim everything and show you exactly where your thing needs to go. So I'm just going to wire it here. And then that's our first track made. Did everyone get that? Yes, yes. Got it. Yes, nice. Okay, great. So now we are going to do that again. So X, next thing, and then X, X, next thing. And then ta-da, we have a line. Okay, so we have all the grounds connected. Did everyone get that? It's not locking in. Straight. Oh. Okay, you have the wrong pin. So what you want to make sure is that it's going to depend on your setup, but you want to make sure that the ground pin goes to the ground of yours, because you're connecting it from the pin. You're connecting it from like this string of text to like another one string of text. Yeah, your ground is on the right. Yeah, that happens. Just connect it from ground to ground or whatever is highlighted. It's going to look different for everyone, unfortunately, because sometimes it just assigns it differently, but you should be fine. You just watch writing with a passion. Yeah, it's kind of fun though. Sometimes, like it sucks at first, but then it's kind of like a puzzle if you think about it. It's so fun. See, Jesslyn gets it. Actually, you know what's funny? While everyone's still writing everything, let's see, PCB. Shoot, I can't find the example, but it was really, really funny because they auto-routed the whole thing. Arcwood. The schematic layout was the only file I had there. Also, actually check Slack real quick. No, I can't do multicolor, but you could paint it if you want. Yeah. That seems awesome though. Like, that'd be cool. What I want to do at the end of this you ship we ship is like take all of the Hackpad submitted, make renders of them all, and then like post it on like Reddit or something. I think that like blow up. I think that'd be sick. Yeah. Okay, cool. So does everyone have their grounds wired? Shipping is done in all country. So It's going to be shipped from the US, but it should go worldwide. You might face some custom stuff. I'll try my best to fix it, but yeah, it's going to be that. Yeah, okay, cool. So we have all the grounds connected, but now we need to connect it to the actual microcontroller. So what we're going to do is basically the same process, but we're going to hit one of these. We're going to hit X. It's going to show us exactly where we need to put it. So I'm just going to put it here. And I'm going to select the next one. I need to put this here. Select the next one. Put that there. And then select that. And it's telling me to put it here. That is routing of all time. Okay. And then lastly, ground goes there. Great. If it's just telling us where to put it, why doesn't it do it itself? Because you can put it different ways. So like, for example, I can take this wire and I could drag it. Oh shoot. I can drag it. I can drag it all around like that. So if I do this, it's still connected, but it looks different than if I do it like that. Like this is really simple, so it can do it itself, but when you get more complicated designs, you you have to deal with like laws of physics basically. Like for example, if you're doing something that's like really high speed and then you have a bunch of wires like all tangled together, your signals are going to get really messed up and then like it's not going to work. But for this, it doesn't really matter that much. Yeah. Okay, does everyone have everything connected or is anyone having issues with that? Can you do right holes on the switch wire when blue so it's on the bottom? Yeah, you can. It's not touching. Well, it should when you route it. Does it like say like are you routing it to where it's highlighted like this? Um, now if that's where it's being highlighted, it should be fine. It's gonna be different for everyone, so. Okay. Yeah, I can imagine I'm not familiar with hardware. Hey, hardware is so fun. Like one thing I really want to push with Hack Club is like more hardware projects, more like, you know. Great. I'm just gonna. Okay, not a robot. If you look like the blue lines on the blue lines in the image you sent, that shows you like where to connect it. So like for example, if I delete this, right here, you see how there's like a blue line that like shows me where it needs to be connected to. So you want to make sure like none of those exist because that means there's like a pending connection. The centers are for me are 17.78 millimeters apart for keys. Can you try dragging them out more? It should be as close to 19 as possible. Oh, that's cute. As long as you drew your schematic correctly, then you shouldn't really have to worry about whether or not it's connected to the right place, as long as you snapped it to the correct thing. Because like, again, when you're trying to route something in KiCad, like it'll only highlight and let you snap to like what it's supposed to go to. Hardware intimidates me. Could I ask what intimidates you? Actually, I'm really curious. The idea that there's no easy undo button. Aha! Welcome to 3D printing. Where? Or welcome to the simulations, 3D printing, and other things. Actually, you can use MX style switches, right? It'll be soldered by you. Yeah, it will be soldered by. Did you ask on the Discord? Let me. No max sockets are fine. Yeah, I'll solder them. I will say they will be 0305, so the lip will be kind of high, but it's pretty usable, all things considered. Through-hole-ish. Well, through-hole basically like okay, so through-hole basically means like okay, just a really quick tangent before we go to the next step. Surface like through-hole basically means it goes through the PCB. Surface mount means it just goes. It's mounted on the PCB. Okay, cool. Does everyone have everything routed? Does anyone need any help with that? If you do have everything routed, please just drop a yes, thank you, or not thank you. Yes, got it. Whatever in chat. Are we allowed an SMD shout? No, because we don't have any of those at HQ, but we have like a giant bag of those of like through hole ones, unfortunately. Trying to space out the keys. Okay. 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 Well, it's 2:30. I'm gonna move on for now. Again, recorded. Always check back. No worries. You won't be lost. You can come back. There'll be more. All that stuff. What if you desolder the headers? I mean, go ahead. Go if you want to desolder the headers, I will approve a surface mount on. If you want to do that. Okay. So we have our PCB, but right now we just have a bunch of floating components. We don't actually have like a board. Like we need to find like a board for it to sit on. Like right now it's just floating. So this is really easy. What you want to do, you want to go to this edge dot cuts layer right here, and then you hit the rectangle tool, and you just want to draw a rectangle. So you want to draw it to match like the edges of this key switch, and then like add a bit of space for the microcontroller. So something like that. Looks good. Let's see what people are saying. Hello. Welcome. Dalbu, we're in the middle of designing the PCB. We're going to get to the case very soon if you are already done your PCB. If you're not done your PCB, what's it called? We're making the grid. So we're making the outlines because like right now in our schematic, we only have a bunch of like floating parts. We need to like define out an actual like board for it to sit on. So all I did, I went to this edge dot cuts layer right here, and then I drew a rectangle. And what that lets us do is like now, ta-da, in our 3D viewer, we have a board. I'm not going to start the AI companion. I'm sorry, Dalbu. Okay, there you go. Can you do it again? Yeah. Okay, so right now we have nothing. So go ahead and click edge dot cuts right here, and then hit this, and then just trace the edge of thing here. That looks good. The PCB should be 100 millimeters or less. Yeah. If it's 101, that's fine. Just don't make it past like 103 or so. So like the key switches, do we just pop them in the PCB? So if you have mil-max sockets, you can just pop them, but you do have to solder them generally. But I will do that for you. Unless you want to solder them. Yeah, that's fine, Oliver. If we want a unique shaped case, no. Okay, so here's the cool part, Jeslyn. You can make your your PCB like a rectangle, and then just make your 3D printed case like a custom shape. And yeah, it's not working. You have to hit the rectangle tool like right here. Draw a rectangle. Yeah, that 919 millimeters is close enough. That 0.05 isn't going to make a difference. Yeah, you could make a custom PCB shape and a custom 3D case, but I haven't made like a really complicated. All I was doing is selection. Oh, you have to click once and then like move it. Don't click and hold. We get 2 extra PCBs. Yeah, that's correct. So if you want to buy another set of parts, go ahead. How do you undo routing? You can just delete it. If you want to undo all of it, you can hit, you can go to edit and hit global deletions. And then if you check tracks and vias right here and click OK, it'll delete all your routing. You can also just Control-Z or like just delete the specific routing you want to do though. But sometimes you just want to restart because everything's just completely messed up. I get it. So there's that. Can we buy another set of parts from Hack Club? I'm gonna say no for now. But yeah, I don't know. I'll show you some PCBs, BGS. I already forgot what we clicked on. Okay, so hit edit global deletions, and then you can check tracks and vias, and then hit that, and that'll delete everything. No worries. Okay, if you're done making like the board outline, can you send a message in chat? Just say, yes, I'm done. Great job. Fantastic. Your favorite joke. Actually, yeah, while we wait on everyone, what is everyone's favorite joke? How long should the should be from the edge of the key to outline? I actually like, I see what you mean. My chat is bugging out. Okay. That's a fantastic question. It should just match the edge of the, should just match the edge of the key switch. Okay. You have jokes? Yeah, Zoom chat just scrolls up for me too. No edge? I'm not sure how it goes in Easy EDA. If anyone knows, could you help them? Otherwise, I can work with you after, all right? Okay, cool. So if everyone, oh my God, I hate Zoom chat. Okay. I can't read people's messages. The USB. Okay, you can just, that'll be fine. Okay, cool. So, congratulations, everyone. You have finished your PCB. One final thing I want us to do before we move on to our case. If you go to the measurement tool, I'm not even following. I'm just to say snarky cost. You know, Ben, I get it. What I want you to do is just go to the edges of here and just quickly measure this. And this will be very useful when we design our case later. So when everyone's like schematic looks something like this with the measurements, drop a message and then we can move on to design the case. how to add the measurements. So if you go to this tool right here, and then you just click the corners of it, it should snap and make like a target like that. And you just click, drag, click, bam, and then it should show you. 61 by 88, yeah, that's fine. We can make long as much as we want. It has to be under 100 millimeters. For this, I would suggest you make it as long as I'm showing you so that you don't run into alignment issues, but yeah. I hate Zoom chat, oh my God. Okay. I can't see people's messages. How do I make the PCB? I made it rectangle. I can't see anything around the parts. If you view 3D viewer, do you see something like this? Yeah, don't worry about that. Don't worry about that. Great. How do I open 3D viewer? So if you go to view and then 3D viewer, it's just a cool thing. I mean, it's nice to be able to see your PCB, I guess. Should USB-C hang from the side? Yeah, yeah. I mean, you can make it not hang from the side too. I just like making it hang from the side. Great. Okay. So I'm going to assume everyone has their PCB done because we have about an hour until we have to until the workshop's over. So we're just gonna move on to case design. All right. So yeah, that's okay. Okay. So what we're gonna do? Can everyone open up Fusion? And then just drop a message in chat when you have Fusion open. You said to use Onshape on Linux earlier? Yeah, it should be similar, although I haven't used it much. Can we go opening a file and stuff? We can use Shaper 3D and stuff. Yeah, you can. It just might be a little different to follow along. Why don't we use something like FreeCAD? Because I am most familiar with Fusion, but that's literally it. You can use Shaper, you can use FreeCAD, you can use Onshape, you can use Tinkercad. You can use, I might pick up Onshape just so that it's easier. Because I know a lot of people have trouble with Fusion. I've been using Fusion for 8 years at this point. So, like it's kind of like it's just kind of what I'd use. What was I making? Random prints. I remember like 5th grade, I 3D modeled like a couple like projects. You were learning? Yeah. No, not in school though. I was just making random projects, random models. They weren't complicated. This project will probably increase my engineering grade by 20% for the Fusion projects. I'm glad to hear that. Okay, so does everyone have their preferred CAD editor or CAD tool of choice open? Yep, 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 yep. Waiting to sign up for Onshape. So, okay, great. I'm just gonna start. So at this point, the steps are going to diverge a bit. So I'm just going to explain it generally. I'm going to complete a whole step, and then we're going to work through, I guess, how to do it in your specific software of choice. So the first thing I'm going to do, I'm going to make a new sketch. Here we go. And then remember the measurements that we drew earlier? Well, we are going to use those measurements to make our case. So I'm going to draw a rectangle with the dimensions I had earlier. So this one is 47.1. And yeah. Hello.
Got a free gift?
Hello.
It's a good gift.
Sorry?
It's a surprise.
Oh. Hi. How did I create a new sketch? So if you hit this button right here, create sketch, and then you could select a plane right.
Good catch,
A level plus gift.
All right, Mohit, I'm gonna mute you for now. Yeah, awesome, thanks. You forgot to put measurements on your PCB. Okay, so what you do, you just go to, what's it called? You just go to this and then go from here to here. And then like, you just click that and then it'll snap here and then you can just drag it up and down. So as I said earlier, rectangle, and then this is 47.1, I think. And then, no, yep. And then this is 76.2 and 76.2. Great. Okay, let me know if you got the rectangle in place. When doing it again? Okay, does orientation matter? Not really. Okay, so how do you make a rectangle fusion? Are you in the sketch? Oh, okay, cool. Okay, I'll just do it really quickly again for CoderKid. So all I did, I hit create sketch, bam, bam. I hit 47.1, 76.2, bam. No worries, CoderKid. Should the box be above the red line or does it not matter? It doesn't matter. You could throw it in the center. I just like doing it above the red line because like, it's just what works best for me, but doesn't really matter. Okay, cool. So now that we're done that, we're gonna make another rectangle. This time, this rectangle is gonna be bigger in all the directions. So we're gonna basically model like the walls of the box. So what I'd like to do, I like to just draw a random thing. And then Fusion has this cool thing called dimension. So if you select two edges right here and then you hit D, you can say how far apart they should be. So I'm gonna do 10 millimeters. And I'm gonna do that for every single side. So 10 there, then 10 there. Bam. Okay, so I know that was a lot, so I'll give you guys a minute to work through that. Let me know if you want me to do anything again. Okay, do it again? Okay, cool. So I'm just gonna, what I did, I drew, oh shoot, okay. I drew a new rectangle, and then I selected the two edges, and I hit D, and then I specified 10 millimeters, and I did that for every single pair. And then lastly, okay, wait up. Okay. Username just bugged out. Okay. Cool. I'm just gonna check the Slack very quickly. Okay. Hello, we should just mounting the PCB. How would you suggest mounting a PCB? Okay, so because we're doing soldered PCBs, I actually suggest just doing like a sandwich mount. So, because if you look at, like, for example, the early, like when I was designing this, you can see I like put a screw hole for the PCB to screw into the plate, but what's it called? Like, you don't really need that if you could just have the plate be part of the case. It's a lot easier to model. Does this look right? Yeah, nice job. Yeah, thanks for dropping the link, David. Where's the other line? Oh, did you make a, can you press the other thing and hit D? Like can you press a vertical line and hit D? So like, shoot. Like just do that and D like that. Yep, there you go. Okay. When you're done with making a case like this, or when you're done with making this sketch, drop a message, and we can move on to adding the holes for it. Done. Got it. Nice. Cool. Holes is where I messed last time. Okay, great. We'll get it right this time. I'm so lost right now. I haven't really used any CAD software before. Okay, no worries. Or you're on Onshape, right? I don't have experience with Onshape, so well, I used it like once. So I'll do some research with that later. If you, oh yeah, David can help with that. But if you what's it called? If I don't know what time it is for you, but I'll have another workshop like half an hour after this one ends. If you want to like continue on that, I guess I could do some research in the meantime. You think you learned this on your own time? Okay, great. Obviously, let me know if you need any help. Tell all your friends about it. Whatever. Okay, cool. So I'm gonna assume everyone has this right now. So what I'm gonna do, next we need to add a screw hole. So what I like to do, we want to use M3 screws. So M3 screws are basically like screws that are 3 millimeters. Shoot, M3 screw. These screws right here, it's the same ones I use in the Orpheus pad. If you look here, you can see these screws all go through. If you want to see something really cool, like you can see how the screw sort of goes through everything. So yeah. Anyways, oh, by the way, would any of you guys be interested in having this as like Hack Club merch you could buy from like a shop or something? Awesome. Okay. So we're gonna add screw holes. So what we're gonna do, we're gonna make a 2.9 millimeter screw hole like that, and then we can just place that anywhere. And what we're gonna do, we're gonna set it to be 5 millimeters away from the margins. So like that. And the reason why we're choosing no heat inserts, right? So we could do heat inserts, and that's probably better. But we could also just screw into the plastic, and that usually works pretty well. What's it called? And so for this like tutorial guide, we're just gonna use, can you use heat inserts? Yeah, absolutely. Matter of fact, this macro pad uses heat inserts. I just did not model it, but yeah. So once you have one of these, we're gonna use we're gonna mirror it to show like, yeah, those would be great. Yeah. What the heck are heat inserts? Okay, heat inserts are basically they're like small brass things that you can melt into plastic. So if we search up heat set inserts, you basically push these into 3D prints, and then they're like it's basically metal threading that you can screw into. Yeah, great. Okay. Can I show you the whole creation? Yeah. So what you want to do, you pick a corner, and then you just use the circle tool, and then you just draw a circle, and then when you press 2.9, and there you go. What web browser is this, by the way? It's Arc. I used to be like a hardcore Firefox user, but I got a MacBook like really recently. So yeah, I don't think it has hold on, Arc browser and Debian. I don't think there's a Linux package. No. So yeah, it's unfortunate. How big are the holes again? 2.9 millimeters. Didn't Arc get exploited? There is a very big possibility it did. There is a possibility. Listen, I threw my privacy out the window a long time ago. It is what it is. I used to be like one of those, LibreWolf, Proton Mail, Tortuga Noda, Graphene OS. I used to be one of those. Yeah. Yeah, graphene. I actually had graphene on my phone for a while. I have a Pixel, but I ended up moving off of it because Google Pay didn't work because the safety net stuff. Anyways, I digress. We are getting really off topic. Okay, guys, case speedrun. What's it called? So we are going to make sure that it's 5 millimeters away on each side. I'm just going to do this really quickly because we are a little short on time. So I'm going to have to do this a little fast, but again, you can always follow along, but okay, cool. So next, once we have all these holes, we are going to extrude everything. So I'm going to hit finish sketch. I'm also going to hit save. And so we're going to extrude everything by, let's just say 4 millimeters. So we select everything here, and then we hit E, and then we can hit like 4, or you could drag it up and down. I'm just going to specify 4 millimeters and hit OK. Does everyone have that? Yep. Wait one moment. Okay, no worries. How's everyone's day going while we're waiting? Four millimeters? Yeah, 4 millimeters. Actually, while we're waiting, what's it called? How good, got a haircut and wasted too many hours on the outline of your PCB. How do you extrude? Hit so what you want to do, I'm just gonna delete this. So if you show your sketch, if you select everything and then you hit E, yeah, the type 4. So E is basically the extrude command. You can also extrude by hitting the button over here. I just use shortcuts because they're nicer. Wednesday, it's Friday. Oh. Could I please repeat the extrude thing? Yeah, no worries. So once you have your sketch over here, I'm going to select this. I'm going to hit the extrude button over here. And then I'm going to drag this up. And then so this is like how much it's extruding by. I'm going to hit 4 for 4 millimeters. There you go. No holes. How do you convert circles to holes? Adi, are you in Fusion? So does your sketch look like this? there are no circles inside the circles for me. I'm kind of, oh, like the black circles. Did you use the circle tool? It should be white. Yeah. Okay. Are you able to select the circle like this and extrude it individually? Yeah, so what you want to do is you want to like constrain it. So if you go like, okay, if I, like right now, I can sort of do this and then drag it around anywhere. If I hit this and I hit this and I hit D, I can like say how far it has to be from the edge. It's all 5 millimeters for me. Okay, Addy and Yi, you guys can come to next workshop, or well, there'll be 2 more today, or you can reach out to me on Slack and I can help you there. Maybe because you need free cat. Yeah, I'm gonna move on just for sake of time because we're really starting to crunch it. So what's it called? Once we have that, we're gonna hit E for, okay, great. So now we have the base. Now we have to make the walls, right? So what we can do, we can select the bottom sketch over here, hit E, and then we're going to extrude this like 20 or so, and then we hit new or join. Okay, so we're just going to do like 20 or 18. Cool. And here's like the bottom wall, okay? And then we have to do the plate. Or, okay, I'm going to speedrun this in like 2 minutes, and then we can work through it slowly. Okay, so now we have the wall. Now we have to make the plate. So we go to keyboard layout editor, which basically allows us to like edit keyboard layouts. And we're going to delete all of this. Then we're going to do that. We're going to add 4 keys, and then we're going to copy the data from that. And then once we have the data from that, we can make a plate generator by using a keyboard plate. And so we copy that, we take that, we download the XF, and then we do that, and then bam, bam, and then insert DXF, and then take that, and then bam, and then -76.2, and then bam. Okay. Maybe have Jessica Cage, maybe have just a case workshop this weekend. How much was the walls extrusion again? I think it was like 18 millimeters. Okay, so I work 9 to 5. I don't want to be hosting workshops over the weekend. Although it might be smart to do that. But yeah, okay. So what did we just do there? Because I know that's a lot. Basically, if you go to basically if we do keyboard mounting styles over here, like you see all these different mounting styles. Like what we just made was like the bottom over here, right? Now we need to make the plate for the switches to sit on, and we may need to make the top frame for it to screw into. Does that make sense, everyone?
I have a really quick question. How much did you extrude the walls by?
Like 18 millimeters, I think. Let me just double check. We can just fusion. That's don't leaks. Shoot. Fusion. Okay, so if we sketch, let me check. Yeah, 18 millimeters.
Okay, thank you.
No worries. You're so lost. How can I select the walls after extrusion? The PCB is hanging in the air. The PCB is not, or yeah, the PCB is hanging in the air, but it's being held up by, the PCB is held up by the switches being caught in the plate. Yeah. That makes sense, yeah. Okay. How do you add the keys? Okay, we'll get to the key. Oh, okay. So, quick meta level overview. we basically, if we go to this graphic right here, this part, we just made the bottom bit over here. We need to make the plate now. And so the way to do that, whenever I move my mouse, the model keeps spinning. Are you in Fusion? Yep, okay. Can I send again? What do you want me to send? Looking for the keys, right. Okay, so you go to keyboardlayouteditor.com, and basically what this lets you do is it lets you create like a keyboard layout. So when you first load the site, it looks like this. You want to drag all of this, and then delete that. So you clear everything. Yeah, that one. Oh shoot, I just DM'd by accident. Thank you. I accidentally DM'd it to someone and said, whoopsies. Okay, there you go. Yeah, that one right there. How you have Fusion 360? Okay, great. So software so much easier than hardware. Okay, but hardware is so much cooler. Look at this. You design this, you can have it in your hand. You can show other people. You can make it a keychain. What's it called? Like, I really want to see people make like keychain macro pads. I think that'd be so cool. Like, you can have it on your bag and other people can see it and they'll be like, whoa, what is that? And it's like, yeah, that's my macro pad from Hack Club. I designed it. But we need 3D printers for it. Yeah, exactly. Okay, right. You could literally design a keychain hole into your PCB. Yeah, exactly. Showing off. Like, it's cool. It's really cool. Macro pad necklace? Yes. Yes. Okay, wait, we are going really off topic. Okay. So, once you have that, go to this link right here. So this link basically takes data from keyboard layout editor and then turns into like a key switch plate. You can see right here. And then if you, well, actually you can't, like, one thing I've been working on, I digress, okay, whatever. Once we're at the AIO3 plate generator, you should paste in data, make sure you have this extra comma at the end, and then when you scroll down, it'll still look like this and hit download DXF. Okay, I'll tell you what I'm working on if you finish this. Okay, the faster we finish this, the more I can tell you guys about it. Okay, so what's it called? So yeah, do this. Would you suggest generating a play if yeah, I would still suggest generating play if you have a rotary encoder. Exclusive workshop 2 leak, maybe, possibly. Yeah, because like you can edit the generated play. I'll show you how. But okay, let me know when you have the DXF downloaded and it looks like you have the 4 squares here. Can you go up? I want to see the JSON. Yeah. So there's an extra comma here. Because you have to add it because if you don't add it, it just shows nothing. It's like this weird bug, but yeah. Will the recording be posted on Slack later? It will probably be posted on YouTube, or I'll try and post on YouTube. Yeah. Shoot, I need to get water after this. I need to take a snip. Oh, yeah, sure. Or I could just paste in the Zoom. Here you go. There you go. Can you guys just send a message when you know, what's it called? When you have that done. And like, again, if you're like really lost right now, like if you're sitting here with your mic muted, your camera off, and you're like, damn, I have no clue what I'm doing. I don't want to ask because I feel like I'm lost. Like, don't worry. Like, I think that's the most normal thing in the world. And like, again, this will be recorded. There'll be more workshops. Just keep going at it. how you use keyboard layout, I make a 3x3 grid. So if you look here, you can change the like location of this. So like if I set like you could edit the location with the X and Y here, and you basically just mess around with that until you have something done. Yeah, no worries. That's great. I like my goal for the end of this is not necessarily for you to have a complete macro pack because that's kind of crazy. 2 hours. What I want is like for you to have like at least a really good base to work off of, and like just I hope you have fun. I hope you have fun. I hope you learned at least something new. Yeah. Okay. Now, how to upload Fusion? Okay, great. So yeah. Do we add what should be on the keys here? No. That's irrelevant. It's just extra data. Okay. When you're ready to like when you have the file downloaded, send a message in chat like right now. Yep. Okay. 1. Yep. 2. Okay. Okay, cool. So we have 20 minutes, so I'm just gonna speed run this. So what you want to do, you want to go create sketch, hit sketch here, go to insert DXF, upload, select from your computer, and then bam. And then it'll show up. Okay. Did we get here? Do you guys want me to do that again? Okay, okay, cool. I'll do that again. Okay, so basically what you want to do, we want to create a new sketch on the, what's it called? We want to create a new sketch on the top of this. So we hit create sketch, hit this, and then we go to insert, and then we want to insert the DXF file that we just downloaded. So we hit select DXF file, select from my computer, and then the file you just downloaded, and hit open. All right, did we get that? Or, okay, I don't think we'll get time to do the whole thing. Okay, here's what we're gonna do. We have 20 minutes. What I'm gonna do, I'm gonna run through the entire thing right now. I'm gonna say everything I'm doing out loud. You guys can watch the recording after, and then afterwards we'll have like 10, 15 minutes where we can just answer questions. All right? Does that sound cool with everyone? All right, cool. Okay, great. So what I'm gonna do, I'm just gonna create that, and then this one microcontroller to do. So right now I'm just creating like a cutout where the microcontroller is gonna sit over here, and then the switches and everything else is gonna be like that, and then I'm just gonna do E3 new body. Okay, and then I'm just gonna do E. There's a cut into that, but like 3 millimeters or -3. I want to make clearance for the RP 2040 that we're going to have, basically. Okay, cool. So that's our plate. And then afterwards, we want to just make our top covers. So we're going to expose microcontroller for this, actually. So here's what we're going to do. That. And then start from here. And then we're just going to do like 6 millimeters. U body. And then bam. Once we have that, we have our whole design, I guess, and then we can do what's it called? You just fillet everything. So I'm just selecting all the edges right now. And then I'm just gonna fillet this by like 5 millimeters. That, and then what else can we do? I mean, yeah, that's basically it. We have the switches. Yeah, okay. So you know what? I'm just gonna call it that. This is basically a working case because the microcontroller sits here, the 4 switches are here, and then everything is held up by screwed in plate stuff over here. You could go ahead and add more detail, but I'm just gonna call it there. But yeah, that's how you make a case. You just have, here, we'll start naming these parts, you know, bottom, and then rename plate, rename top. And so if you look at, or actually here, we can look at this from like a cross section. But yeah, built it. Okay. But if you like look at keyboard mounting, if you look at keyboard mounting styles right here, as you can see, we have thing. Yeah, that's basically it. Okay. Ta-da. Guys, I've had a very long day. But yeah, we still have like 15 minutes. So I'll just take questions and talk for a bit because I think that'd be better. But yeah, that's basically how you make a macro pad. I'm sorry the CAD part was a little rushed, but you can watch this over. You can literally copy my keystrokes and it should work. How do I get the PCB in it? Right, we could do that. KiCad has an awesome feature called export as step, where you can export it as a step file. But so if we, so if you export as a step there, and then you can file, open from my computer. We can open this, and then ta-da, it's your PCB. Have to be sweet. Well, yeah, well, you have to be able to put in the PCB somehow. But yeah. Anyways, and then you can have more like advanced exports. Like this is, like I'm so proud of this thing. Yeah, you have to make it separately, or else like the PCB is not going to be able to put in. Also, where will I get the? Okay, so I'll post the recordings on YouTube and send it. I hope I can get out by the end of today, maybe tomorrow. For my MCU, did I make the hole in the case line up with it? Yeah. So, if you, I mean, this took a bit of trial and error, but like this is like 2 scale. So as you can see, I guess the USB-C thing clips a bit, but don't worry about that. This is like an older version, I think, but USB-C thing is like lined up, and then I have a microcontroller, and then yeah, this is like as accurate as it gets, basically. Should I export 3 different step files? Yeah. Or well, no, 1 step file should be able to have everything in it. So now everything's done. We just need to arrange files and make a PR. Well, you also need to do the firmware, which is basically. It's up to you on how you want to do that. But you need to do firmware. Yeah. Okay. Oh, I do want to show the gap in front. Sure, as long as it fits. Oh, by the way, why add that as a requirement? Add firmware. Oh, because okay, I want well, you can also make your own firmware. KMK or QMK. So the reason why I made firmware like a requirement is because I want people to make like full stack projects. You know, like I don't like I think it's really cool. Like, oh, I just made a CAD project. Oh, I just made PCB. Oh, I just made a software, but like piece of software. But I think like the really cool magic of it is when you like combine all of it together to make like something that works. When you make something like complex that's like physical and it works. Like for example, my capstone project was neutrino, right? Or not capstone, but just this is like one of my what exactly is firmware and QMK. Okay, so firmware is like what's it called? Firmware is like it's basically like the code that runs. It's like the I made the neutrino. Yeah. Have you heard of this? David? All right, I guess I'll keep going. But like my main project was like a 3D printer that fits inside a box. So for that, I had to do like software. I had to do PCB. I had to do the full stack, and I think there was like a lot of. I learned a ton doing that, and I feel like we don't get enough projects that are like full engineering jobs like this. I feel like we get projects that are like really into one thing, which is cool. But I think by combining like other disciplines, you can create like much more complex things. Will Forge be similar? Well, okay. Well, I don't know what's up with Forge. To be honest, Forge uses a very different design than what I went for. But yeah. But that's sort of my rationale for it. There's like a lot I need to work on in terms of like communicating everything because I think a lot of things are unclear. But yeah. This was the thing I worked on. If the code doesn't work, will not get approved. So here's how it's gonna work. I'm gonna do like an overview of your code just to make sure like it seems sane. And then I'm actually gonna test that HQ. If it doesn't work, I'll give you the chance to like actually fix it because these things are like messy, of course. But yeah, like don't I wouldn't worry about that. Just try your best. You need to okay. So what am I working on? Well, it's nothing like super specific, but I've basically been trying to like think about and like research of ways to like make like what would typically be purely software like web applications into like something that you can interact with more in the hardware like in hardware and like in the real world. Because hello Kashpreet. So we're the workshop's sort of over, but we do have another one in like half an hour. Oh, wait, David, have you heard of Neutrino? From wait, where do you find out about it? Wait, where do you find out about Neutrino? Wait, I'm really curious. After the positron? Did you see it in like the positron Discord server or like you're just browsing? Wait, like browsing where? I'm really curious. That's crazy. Wait, I'm wow. Okay, well, yeah, that's me. No, it exists. It's a real like. If you look at my screen right here, it's a real printer. I designed. It's at HQ right now. Hey guys, can you wait like well you can't order it. It's an open source design, but wait like 2 minutes. I'm gonna get it right now. Okay. Ta-da! neutrino in a box. But no, it's not in the Slack. So I built this, or like I designed this before. What's it called? I designed this before I found out about Hack Club, like earlier in March. So there's nothing. It's not really Hack Club related. It's sort of my own personal project. Show up. We can't see. Okay, so about that, the self-replicating stuff actually did get finished. I just never uploaded it. What's it called? The PET bottle stuff. Shoot, I don't even know if I still have the notes for that. I did like a bunch of math with it. Like I don't know where you're at with math. But, like one idea I had was like probing multiple points and then doing like a what's it called? Like a linear. Fuck, I forgot the term, but basically, I probe a bunch of points. I get their coordinate. I take the plastic strip. I probe a bunch of points to get the curve and approximate it with a function, and then I take the function and then I add a y offset that's equal to the thickness of the bottle, and then I integrate both, and I take the difference of their I take the difference of their integrals, and then I compute that as a volume to get the relative pressure of the plastic so that it prints properly. But I never really got around to finishing that, and I don't know if any of that made sense. It was a lot of math. Do I do discussions about my personal projects on your channel, Alex Containment Chamber? I don't, but honestly, maybe I should. What's it called? Will you guys be interested in that, I guess? Of course? Okay. You know, maybe I should. Okay, great. I'll post about it after that. Okay. That'd be great. And I think, will you be adding more projects to the open area like Hackpad? So the open area was basically my idea of like Hack Club. Or like, so before I found out about Hack Club, I cared a lot about. Actually, I'm just gonna answer the question real quick. What are the margins between each of the switches? 19.5 millimeters between each center. Okay. 19.05. Sorry, I'll just reply 19.05 between the centers. So I'll answer you questions first before I get you Coder Kid. But basically, before I found out about Hack Club, I cared a lot about like accessibility and like just information, like getting people, like just anyone who is generally considered like not super good at tech to like believe that they can like make things. And so I sort of designed Neutrino around that. And this is sort of how I got involved with Hack Club, because like while I was on this like personal mission, I ran into Zach. I ran into Leo McElroy, if any of you remember him, and Zach. And so talking Zach, talking about all these values, it's like he's like, hey, you should get involved with Hack Club. And so that's why I'm here. But the open area is sort of shelved for now. Like it exists, but I'm more so directing my efforts to Hack Club and like using Hack Club as like a platform for enacting like similar goals. Yeah. Do you get paid from Hack Club? Yeah, I work here full time. This is Zach's office that I'm stealing. But what's the other question? Am I more into coding or just hardware stuff? I think recently I've been getting a lot more into like coding, like data processing and stuff. But I think historically it's mostly been hardware stuff. So yeah. Joma Tech. I do not. Let's see. I talk about life in Silicon Valley. Oh wait, I've seen no. I watched his videos before. Never mind. Yeah. What's it called? What about him? I look like him. Wow. Okay. Oh, Space Winnie. That's funny. Do I? I don't really see it, but okay. Okay. anyways. Joan Tech. Guys, do I look like him? No. Any suggestions for outline and KiCad? You're really struggling with it? KiCad edge cuts. Maybe try this YouTube video. I honestly don't know. Just search up like YouTube videos. Hello, Ember, is that how I pronounce your name? Yeah, let me know if you still have trouble with it. But yeah. Hello, Coder Kid. I see this website. Oh, I like this. Wait, this is really cool. Wait, did you make all this yourself? Wait, shoot. Can I show this to other people? Like, can I put this on my main screen? Okay, wait, I'm gonna, hold on. Guys, look at this. Where are we? Look at this. I love the aesthetic. That's awesome. Figma. How did you set distance from the Figma stuff to outlines on the PCB? So what I do, what's it called? So like basically I just overlaid images of like the PCB, and then like I just drew over it. So if you look here, it's like I drew over it and then I would export it, and then I like exported it on as like a graphic. And so if you, oh shoot, you can't see my Figma. Okay. Like basically I would overlay it onto like the PCB and the CAD, and then draw like the actual thing after. How do I add that to KiCad? So you can export it as a PNG, and then the KiCad has a tool. KiCad has a tool somewhere. I'll just close this. Right, KiCad has like an image converter where you can convert like images into where you can convert like images into like footprints, which is really useful. Okay, cool. Country, can you post that in just like the Hackpad channel? I'm gonna be calling it here. I'm just gonna say reply you're here from the workshop. Okay, go to my personal channel and then like reply if you're here from workshop, so I know who you are. Or like just anyone here who wants to like hear more about my, I guess, personal projects, if you guys find that cool. Yeah, I think we're gonna call it there. Because there's another workshop happening in like half an hour. So do I answer DMs if you have an issue? I try my best to answer DMs. I get like a billion of them per day. So if you ever miss it, if I ever miss it, just ping me. Like I don't mind. You could ping me like 50 times. I don't care. Okay, like if I find it annoying, I'll let you know. All right, cool. Bye everyone. That was great.
Bye. It was really cool.
Thank you.
Bye, friends.